Motion tracking data create new opportunities to perform detailed and comprehensive analyses of a variety of complex human behavior. Especially, analyzing patterns in natural human motions can help researchers better understand human behavior. We introduced MotionFlow, a visual analytics system that supports researchers in performing pattern analyses of human motion with motion tracking data. MotionFlow consists of four main views. The pose tree view provides a simplified representation of multiple human motion sequences by aggregating the same patterns into a tree diagram. The tree map view is an alternative representation of the motion data using a space-filling layout. Motion graph view is a node link diagram of pose clusters. This view supports the users to generate representative pose states through an interactive clustering approach. Lastly, MotionFlow features an animation view that allows the users to explore individual data or multiple data through a detailed view of the motion sequence. To provide a visual summary of multiple motion data, we formalize motion tracking data with representative pose states. We use a motion graph layout where each node represents a poselet, where a pose cluster is embedded and edges encode a pose state transition. To help the users better understand the configuration of a human pose, we enable the user to control the view of each node by dragging the mouse around a node. By clicking any pose cluster node in the motion graph view, the system highlights the corresponding node in the pose tree visualization. We involve the user in generating the pose states through an interactive clustering approach. We provide a slider bar interaction to control the global level of pose clustering. We also provide a split and merge feature for pose clusters to control the clustering process at a local level. To keep some desired pose states throughout the clustering process, we allow the user to lock the pose clusters. In the pose tree visualization, we simplify the motion sequences with representative pose states as tree nodes, and the frequency of motion transitions is encoded by a flow visualization on the edges. We provide zooming and panning on the pose tree view so that the user can focus on a detailed display of specific regions of interest. We also provide a separate window dedicated to display sub-pose trees, as per the user's selection and search of similar motion patterns. In the tree map visualization, the same color scheme of pose tree is applied, and the two views are linked to each other. Also, by selecting a tree map item or a pose tree node, the user is able to play corresponding animations. To support organization of an unlabeled or an unstructured motion database, we provide a multi-tab interface where the user is able to create a new window tab with desired unique motion patterns. In this case, we seek the most frequent pattern from the data. As a result of creating a new tab, only pose states included in the pattern tab are highlighted, while the others are grayed out in the motion graph view. In the tree map view, organized motion data is represented by a diagonal hash, and currently selected data is highlighted by a hash pattern. To further refine the pose tree structure as a visual summary of the corresponding motion pattern, the user is able to manipulate associated pose states in the motion graph view. As a result of this refining process, we can find an outlier tree branch from the main stream, and then we remove this data from the pattern tab. The user is able to dynamically create, remove, and add motion data to each tab. Also, they can change the name of each tab so that they can designate proper context of the motion pattern.